So if you have any questions, please type them in the text box. So last time we finished section 3.3. Let's start section 3.4, equations of a line. So let me give you the general form for the equation of a line. And so the general form for the equation of a line has the form ax plus by plus c equals 0. Note that all lines in the plane can be put into the general form. However, every line has an infinite number of general forms. For the equation of the same line. So unfortunately, this form for the equation of a line is not unique. There's an infinite number of equivalent forms for the equation of a line if you write it in general form. So in general, we have some arbitrary decisions that we make, rules that we give, so that we only have really one form for the general form. So, um, if we can write it in the following form, it will be um, unique. So if A, B, and C are integers, with A being greater than 0 and we assume that there are no common factors for A, B, and C. So the greatest common factor between A, B, and C is 1. So that means that these are relatively prime. Then the general form for the equation of a line will be unique. So we usually put these restrictions on the equation, the general form for the equation of a line, just so that we can give you one form for the answer. So when you do it on the computer, they'll ask you to do these things to be sure that the constant in front of x is positive and that there are no common factors and that everything is an integer. All the coefficients are integers. Um, so usually we use this. So use this form when determining the distance to a line. So for example, the distance from the point well, let's say x0, y0 to the line ax plus by plus c equaling 0 is given by the distance is just ax0 plus by0 plus c, all divided by the square root of a squared plus b squared. So that's the distance from a point x0, y0 to the line. Um, Let me give you the standard form. So the standard form for the equation of a line is just ax plus by equals c. Again, it looks almost identical to the general form. All lines in the plane can be put into the standard form. Every line has an infinite number of standard forms for the equation of the same line and so again we usually put a restriction on the coefficients a, b, and c so that we only have a one standard form. So if we can find a, b, c, and these are all integers, with a being greater than 0, and we have that these coefficients are relatively prime, so the greatest common factor between a, b, and c is 1, then the standard form for the equation of a line will be unique. Usually we use this when dealing with more than one line. So usually we will use this when dealing with systems of lines, systems of linear equations. Okay. Next, the slope-intercept form. So the slope-intercept form for the equation of a line is y equal mx plus b. M in this case is the slope of your line. B is the y coordinate of the y-intercept for this line. Since you have a slope, you obviously have to have, there must exist a slope, and so you cannot have vertical lines. So um, this cannot be used for vertical lines. So when do we usually use this? Well, usually if you want to determine the slope of a line given by an equation. And so this is what we did last time. So we put a linear equation into the slope-intercept form, and then from there we could determine the slope of the line. Next, point slope. Form for the equation of a line. Y minus y1 equals m x minus x1. And so m is the slope of your line, and, well, x1, y1 is a point on the line. Again, since you have to know the slope of your line, then this cannot be used for vertical lines. In general, this is the form that is always the easiest form to use. So almost always. So you will use this form in almost every case. So it's just the few cases that I have given above, except for those special cases. Given above. Well, and below, actually. So, in general, you'll always be using the point slope form for the equation of a line, except for, say, if you want to find the distance from between two lines or distance from a point to a line, use the general form. If you happen to be looking at more than one line, use the standard form. If you happen to want to determine the slope of a line given by an equation, then use the slope-intercept form. But in general, almost every time you'll use the point-slope form. That's the easiest form. In high school, they usually have you always put in the slope-intercept form because that's usually the most algebraically difficult one to do. And so they're checking that you know how to do your arithmetic. But I assume you know how to do arithmetic, so I'm not going to make you go into slope-intercept form. Okay, so next, the two-point form. The two-point form for the equation of a line is just y minus y1 over x minus x1 equaling y2 minus y1 over x2 minus x1. Okay. So in this case, I'm assuming that x1, y1, and x2, y2 are two distinct points on the line. And I'm assuming that, x1 is not equal to x2, so I'm not dividing by 0. And of course, since I have to have a slope, then this means that this cannot be used for a vertical line. So this form cannot be used. Whoops. Uh-oh. Come back. Okay, let's check. It probably went out. Okay, so let's see. I'm gonna have to restart this. Come on. Hosting notification, now sharing. Good. Okay, so now people should be able to see the background again, right? Hopefully, yes. Yes, okay, good. Oh, and let me just turn that off for a second. Okay. Let's see, so this form cannot, here it is, be used for a vertical line. When do you use this? Actually, I never use this. So I guess use when you're told to, when specified to use it. To use this form. So I've actually never used this form other than when I've been forced to use it, saying use this form. Other than that, I've never used it. Next, the intercept form. For the equation of a line. So the intercept form for the equation of a line is x over a plus y over b equals 1. This is actually very similar to, other equations for your line. Other equations for other types of, there it is. Objects such as, say, the equation of ellipse, a hyperbola, etc. And so this is a fairly standard form. A here is the x-coordinate of the x-intercept. B here is the y-coordinate of the y-intercept. So, of course, A must exist, B must exist, and neither A nor B can be 0. And so this cannot be used. This form cannot be used. For vertical lines. Nor for horizontal lines. nor for lines passing through the origin. Um, so I use this, so use this when you know both the x and the y intercepts and both intercepts are non-zero. Okay. Next, the equation of a vertical line. In general, the equation of a vertical line is just x equal a. The equation of a horizontal line is just y equal b. So let's do on page 131. Let's do, I guess, probably problem number 2. In exercises 1 through 10, find the equation of the line. And so the slope equals 5 halves, and the y-intercept is the point 0, -1. Okay, so so since this has a slope and the intercept, then let's use the slope-intercept form for the equation of a line. Y equal mx plus b. In this case, m is 5 halves, b is a -1. And so the equation of my line is just y equal 5 halves x minus 1. Let me do problem number 6. The slope is -1/3, and the y-intercept, the y-coordinate of the y-intercept, is 3 halves. So I have a slope and intercept. Let's use the slope-intercept form. Oh, y -1. Because the y-coordinate of the y-intercept is b. And so since the y-coordinate of the y-intercept is b, -1, then b here is -1. So the slope-intercept form is y equal mx plus b. Yes, our notation is that the slope is denoted by m. The x-coordinate of the x-intercept is denoted by a. Aha. And the y-coordinate of the y-intercept is denoted by b. So this is actually the x-coordinate of the x-intercept. This is actually the y-coordinate of the y-intercept. Okay, so that's the usual notation for lines. Okay, let me do problem number 20, oops, 22. And so in exercises 11 through 22, graph the line for which the slope m and one of its points is given. So let me do that. M equals 5 halves, and the point is 4, -2. And let me check what the question is. So that, right, so I have here the point, the y-intercept, maybe I should write that, the y-intercept for number 6 was given as 0, -3 halves, which means that B is equal to -3 halves. Since that's the y-coordinate of the y-intercept. Okay. Okay, so let's do problem number 22. So I have here, I start with a point, 4, -2, and then I'm going to use the slope to find another point on that line. So let's see if I can do that. Oops. So let's say 1, 2, 3, 4. Okay, so I'm at 4, -2. So now I'm going to use the slope, which is rise over run. Okay, so I have a run of 2, and then I have a rise of 5. So 1, 2, 3, 4, 5. So I'm going to go up 5. So 1, 2, 3, 4, 5. And now this is the graph of my line. So I have here a rise of 5 and a run of 2, starting at the point 4, -2. Let me do problem number, okay, sure. So I start at the point 4, -2. So I'm here at the point 4, -2. So I go in the x direction 4, y direction, I go down 2. I start at that point. Now I have a run of 2, so I go 2 in the positive x direction, and I have a rise of 5, so I go an additional 5 units in the positive y direction to get to another point on my line. I can then draw a line connecting those 2 points, and that is the graph of this line having a slope of 5/2 passing through the point 4, -2. Let me do problem number 14. The slope is -3/2, and I'm going to go through the point 2, -2. Okay, and so let me write the slope as rise over run. Now I have a negative out in front. I can either put the negative in the numerator or denominator, but I can't do it in both. Now, just for simplicity's sake, I'll say that I'll always put the negative in the numerator. And so, just so that we are all on the same page, whenever I have a slope, the negative will be in the numerator. So that means that I'll always be moving to the right. So I'll always be reading these from left to right. Okay, so now let's graph this. Now it'll be a little bit bigger. Okay, so 1, 2, 1, 2, 5, 5, 6. Okay, so I'm at the point 2, -2. So I start at the point that they tell me to start at, and then I use the slope. And so I have a run of 2. Oh, maybe I should put this a little higher. So I'm here at the point 2, -2. So now I have a run of 2, because that's my denominator is 2. And then I have a rise at -3, which means I'm going to go down 3. So 1, 2, 3. I guess I have to extend this a little longer. And so I'm arrived here. So I have a rise, which in this case is a negative rise, of 3, and I have a run of 2. And so now I can draw the line connecting these 2 points. Oh, darn. Okay. And so oh well. Black. Oh, come on, stop. Let's see, do I have to? I think people may have gone out. Okay, let's see. Let's do this again. And do this. Okay, can you see the screen again? Yes, okay. Okay, so sorry about that. So I started at the point 2, -2. So I go 2 in the positive x direction. I go down 2 in the y direction. That gives me to a point on my line. Oops. That gets me to a point on my line. I then use the slope. So I go 2 in the positive x direction, since I have a positive 2 in the denominator. And I go 3 in the negative y direction. So I go down 3 to find another point on the line, and I just draw a line connecting those 2 points. Let me do problem number 12. And so let's say that we go through the point 2, 4, and I have a slope of 2. Well, if you may have noticed, in this case, when dealing with slopes, it's actually easier to deal with fractions because we have a rise over a run. And so let me rewrite 2 as 2 over 1. So certainly 2 divided by 1 is 2. And now I can say that my rise is 2 and my run is 1. So if I happen to have some quantity that's not a fraction, write it over 1 and then it will be a fraction. And so let me draw this. And so 1, 2, 8, 2. Good enough. And so I'm here at the point 2, 4. 2, 4. And now I'm going to go 1 in the x. So I have a run of 1, and I have a rise of 2. And that gets me to another point on the line. And now let me draw a line connecting these 2 points. And so it looks something like and that is the graph of my the line passing through 2, 4, having a slope of 2. Let me do problem number 20. The slope is undefined, and I go through the point 4, 1. So I go through the point 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 1, 2, 3, 6, 7. Okay, so I go through the point 1, 2, 3, 4, 1. And well, I can't have any sort of run, and so it's just a rise. And so the graph is just a vertical line. Well, close enough. There. It's just a vertical line. It doesn't look vertical. It's a little... Okay, so let's try this again. Okay, good enough. 4, 1. There it is. And so this is the graph of a vertical line. Vertical lines do not have any slope. The slopes are undefined for vertical lines. The slope of a vertical line is infinite. Let me do problem number 18. Slope is 0. Well, it passes through the point -1, -3, and the slope is 0. Let me write 0 is 0 over 1. And so this is my rise, and this is my run. Okay. And so I have the following: 1, 2, 3, 4, 5, 6. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. So I'm here at -1, -3. And that is a point on my line. Next, I have a run of 1 and a rise of 0. So I have here a run of 1, but a rise of 0. So I don't go up at all. And so it's there. And so now let's draw a horizontal line passing through those 2 points. And so this is a horizontal line. Let me do problem number, well, let's say 56. In exercises 53 through 60, rewrite the equation in slope-intercept form. So let's do that. 2x plus 3y equals 5. Okay, so I want to rewrite this in slope-intercept form. And so let me try to solve this equation for y. And so let me subtract 2x from both sides of my equation. And so I get 3y is equal to -2x plus 5. Let me divide both sides of my equation by 3 in order to solve for y. And so I get that y equals -2/3 x plus 5/3. And that is the equation written in slope-intercept form. Let me do problem number 64. And so in exercises 61 through 68, rewrite the equation in standard form. So y equals 2x plus 9 halves. And when I write in standard form, I should write it in the form where all the coefficients are integer valued, where the coefficient in front of x is positive, and where there are no common factors. So I'm going to do that. So why don't I, in this case, multiply, well, let me subtract 2x from both sides of my equation. And so I have -2x plus y equals 9 halves. So this is in standard form, but it's not in the standard form that we like because this is one of an infinite number of differing equivalent standard forms. So let me write the preferred standard form. So let me multiply both sides of my equation by -2. Negative because I want the number in front of x to be positive. 2 because I want to get rid of the all of the denominators. And so I multiply by the least common denominator, which is 2. -2 times -2 is a +4. Negative 2 times y is negative 2y. The 2's cancel, so I get a negative 9. And now that is in standard form. Notice that 4, negative 2, and negative 9 are all integers. Next, note that 4 is greater than 0. And lastly, note that the greatest common factor of 4, 2, and 9 is 1. And so, well, maybe I'll say the negatives, but it doesn't matter. And so note that this is if I have these three conditions being satisfied, then there's really one unique form. And so we sort of like that. Let me do problem number 26. And so problem number 26. Oh yeah, let me do 26. M equals 1/2 and passes through 3, 1. Yes. 64. Question? Explain. Okay, so if you recall, when we do a standard form, here it is. The standard form. The standard form for the equation of a line is ax plus by equals c. But there's an infinite number of differing standard forms. If I want it to be unique, then I want all the coefficients to be integer valued. I want the number in front of x to be positive, and I want no common factors. And so, to get into standard form, all I need to do is have x's and y's both on the same side of the equation and the constants on the other side. And so negative 2x plus y equaling 9/2 is in standard form, but it's not unique. There are many differing other answers. Matter of fact, the one below is another answer, another form that's equivalent in standard form for the same line. So since we want just one answer, what we do is we want all the numbers, all these coefficients here, to be integer valued. Next, I want the number in front of x to be positive. And next, I want no common factors. And so, if I multiply every term here by negative 2, then I'll satisfy greatest common factor. Oh, um, what can you divide? What can you divide 4, 2, and 9 by? Well, you can divide 4 and 2 by 2, but you can't divide 4 and 9 by anything other than divide it evenly by anything other than 1. So the only integer, let's just talk about natural numbers. If I look at the number 4 and 9, the only natural number that divides it evenly is 1. And so if that occurs, then we say that it's relatively prime. And so that GCF just means, well, what's the largest factor that's in common between 2, 4, and 9? Well, the largest number in common between 2, 4, and 9 I can factor it is just 1. I can't divide 9. I can only divide 9 by 1, 3, and 9. I can only divide 4 by 1, 2, and 4. I can only divide 2 by 1 and 2. So the greatest thing that's in common, So the factors of 4 are 1, 2, and 4. The factors of 2 are 1 and 2. Those are the only things that if you multiply them together, you get 2, the only natural numbers. And the factors of 9 are 1, 3, and 9. So I look at things that are in common. Well, the 2's are in common, but it has to be in common with everything. Well, there's nothing in common other than, oops, the only thing in common is 1. Therefore, that's the common factor, and it's the largest, so it's the greatest common factor. So the greatest common factor is 1 because they're all in common between these three numbers. Is that clear? So it's GCF is the greatest common factor. Okay, good. Let me do problem number 26. So again, let me find the equation. So in exercises, give us find the equation. Oh, find the equation. Aha, 26. So in exercises 23 through 38, find the equation of the line in slope-intercept form with the given slope passing through the given point. Okay, so I have here a slope and a point. So first let me put this into the point slope form. And so, oops. And so y minus y1 equals mx minus x1. And so, in this case, this is x1, y1. And so I have here y minus 1 equals m, which is 1/2, x minus x1, 3. Let me multiply 1/2 inside the parentheses. So I'd be done, except that they told me to put this into slope-intercept form. So let's multiply 1/2 inside the parentheses. So I get y. So I get y minus 1 equals 1/2 x minus 3/2. Let me multiply both sides of my equation by 2 just to get rid of the fractions. And so I have 2y minus 2 equals x minus 3. Let me add 2 to both sides of my equation in order to isolate y on one side of my equation. So 2y is equal to x minus 1. Now let me try to solve for y. So let me divide both sides of my equation by 2. And so I get y equals 1/2 x minus 1/2. And that is in slope-intercept form. Y equal mx plus b. Let me do problem number 70. And so, in exercises 69 through 80, find the equation of the line with the given 2 points, and you're going to write this in standard form. Okay, so let me do that. So problem number 70. 2, 1, and -3, 4. So I'll call this x1, y1, and this point x2, y2. Okay, so first let's determine the slope of your line through 2 points. And so m equals y2 minus y1 over x2 minus x1. Okay, and so 4 minus 1 over -3 minus 2 is equal to 3 over -5. So my slope is equal to -3/5. Oh, thank you. Hopefully I said y2 minus y1. Ah, things keep disappearing. Y2 minus y1 over x2 minus x1. Okay, there. Thank you. Okay, so that's the slope. Now let's determine the equation of a line. So let's do the point slope form. Point slope form for the equation of a line: y minus y1 equals m x minus x1. So y minus y1, 1, equals m, -3 halves, x minus x1, 2. Again, I'd be done, except that they want this written in standard form. So let me multiply the -3/5 inside the parentheses. So I have y minus 1 equals -3/5 x. Negative times negative is positive. 3 times 2 is 6/5. Now, let me get rid of all the fractions. So let me multiply both sides of my equation by 5. So I have 5y minus 5 equals -3x plus 6. And so I want to put this into standard form. So let me bring all x's and y's to one side of my equation. So let me add 3x to both sides of my equation. And so I get 3x plus 5y minus 5 equals 6. Let me add 5 to both sides of my equation. So 3x plus 5y equals 11. Well, each of these coefficients are integer valued. They're all the coefficient in front of x is greater than 0, and there are no common factors. And so this is in standard form. With a being greater than 0, well, with a, b, and c being integers, a being greater than 0, and with the greatest common factor equaling 1. And so I've written this uniquely with these added conditions that I've specified. Let me do problem number 80. And so suppose I have the points 5, 4, 4/5, and 13/4, and 9/5. Okay. So I guess I'll call this x1, y1. I'll call this x2, y2. So let's find the slope of the line through 2 points. And so the slope is just y2 minus y1 over x2 minus x1. And so, oh, this is going to have to be huge. So it's 13/4. Uh, it's 9/5 minus 4/5 over 13/4 minus 5/4. So it is y2 minus y1 over x2 minus x1. Well, these have nice common denominators. And so 9/5 minus 4/5 is 5/5. 13/4 minus 5/4 is 8/4. 5/5 is 1. 8/4 is 2. So the slope is 1/2. And so now let's use the fact that we have 2 points, and well, a point and a slope. So let's use the point slope form. For the equation of a line, y minus y1 equals mx minus x1. And so y minus y1, 4/5 equals m, 1/2, x minus x1, 5/4. And so let me multiply 1/2 inside the parentheses. And so I get y minus 4/5 equals 1/2 x minus 1 times 5 is 5, 2 times 4 is 8. Let me multiply both sides of my equation by, oops, let's multiply by, ooh, that's going to be a 5 and a 4. Let's do it by negative 40. And so I get negative 40y. Negative and negative makes that a positive. 40 divided by 5 is 8 times 4 is 32 equals. Negative times positive is negative. 40 divided by 2 is 20. Negative times negative is positive. 40 divided by 8 is 5 times 5 is 25. Let me add 20x to both sides of my equation so that all x's and y's are on one side of my equation. And so I have 20x minus 40y plus 32 equals 25. Let me subtract 32 from both sides of my equation. And so I get 20x minus 40y equals negative 7. And so I have that all of these coefficients are integer valued. The coefficient in front of x is positive, and there are no common factors. And so I've written this in standard form. Let me do problem number 40. In exercises 39 through 52, find the equation of the line in standard form with the given conditions. And so it passes through (41) and it's parallel to (4x) plus 4y plus 7 equals 0. Okay, so let's do that. So first, I want to determine the slope of the line 4x plus 4y plus 7 equals 0. And so, to find the slope of a line with given by an equation, I want to put it into slope-intercept form. So let me subtract 4x from both sides of my equation, subtract 7 from both sides of my equation, in order to isolate y on one side of my equation. So 4y is equal to negative 4x minus 7. Lastly, let me divide both sides of my equation by 4. And so y is equal to negative 1x minus 7/4. Okay, and so in this case, the slope of this line is negative 1. Therefore, since parallel lines have equal slopes, then the slope of a line parallel to it will also have a slope of negative 1. So now I'll use the point slope form for the equation of a line. I have a point and I have a slope. And so y minus y1 equals mx minus x1. y1 is 1, m is negative 1, x1 is 1. Let me multiply negative 1 inside the parentheses. And so I have y minus 1 equals negative x plus 1. Again, I would be done if they would allow me to write the equation of a line just in point slope form, but they want me to write it in standard form. And so let me add x to both sides of my equation. Let me add 1 to both sides of my equation. And so I have here x plus y equals 2. Well, all the coefficients are integer valued. The number coefficient in front of x is positive, and we have no common factors between all these coefficients. And so I've written it in standard form, in the preferred standard form. Let me do problem number 42. So it passes through the point 4, -5, and it is perpendicular to the line 3x plus 4y plus 5 equals 0. So again, the first thing I want to do is I want to determine the slope of the line. So I'm going to put it into slope-intercept form. Okay, and so let me solve this equation. For y, let me subtract 3x, 5 from both sides of my equation. So I have here that 4y is equal to negative 3x minus 5. Let me divide both sides of my equation by 4. And so I have that y is equal to negative 3/4 x minus 5/4. So therefore, the slope of my line is a negative 3/4. The slope of a line perpendicular to a line is equal to its negative reciprocal. So let's take the negative reciprocal of this slope. So I'm going to change the sign from negative to positive, and I'm going to interchange numerator and denominator. Therefore, the slope of a line perpendicular will have a slope of 4/3. Now, I have here a point and a slope. So let's use the point slope form for the equation of a line. Y minus y1 equals mx minus x1. What about the negative side? So remember that if you have a line that's perpendicular to another line, it's equal to its negative reciprocal. So I've got to change the sign and flip. So I both change sign and I flip it when I find the slope of a line perpendicular. Okay? And so I have the point x1, y1. And I have my slope. And so I have y minus y1, which is a negative 5. So y minus a negative 5 is the same as y plus 5 equals m, which is 4/3, x minus x1, which is 4. Again, I would be done. This is the equation of the line, but we want to write it in standard form. So let me multiply negative 4/3 inside the parentheses. And so I have y plus 5 equals 4/3 x. Positive times negative is negative. 4 times 4 is 16. 3 times 1 is 3. Let me multiply both sides of my equation by negative 3. And so I have negative 3y minus 15 is equal to negative 4x plus 16. Let me add 4x. Why negative? Because I want a positive in front of the x. So notice that when I flip it to the other side, so notice if there was I now have a negative 4x. So when I bring it to the other side of my equation, it becomes a positive 4x. and I want a positive number in front of my x. And so that's why I multiply by a negative, so that when I brought it to the other side, it would become positive. You don't have to do that all in one step. You can always, at the end, change your sign if you don't have it correct. Yeah. Okay, so now I have here 4x oops, 4x minus 3y equals 31. And so now notice that all of this is in standard form, and all of the coefficients are integer valued. The coefficient in front of x is positive, and there are no common factors. Let me do problem number 52. So now it passes through. Six, -4, and it's perpendicular to 4x equaling 2y minus 3. So let me try to find the slope of this line. So I want to put this into slope-intercept form. Okay, so let me solve this equation for y. So let me add 3 to both sides of my equation. And so I have here that 2y is equal to 4x plus 3. Let me divide every term here by 2. And so y is equal to 2x plus 3 halves. So therefore the slope of my line is 2. I want to find the slope of a line perpendicular to it. And so I want the negative reciprocal. So I change it from positive to negative, and I find the reciprocal at 2, which is 1/2. So now I have a point and a slope. So I'll use the point slope form. Let's call this x1, y1. And so y minus y1 equals mx minus x1. And so y minus y1, -4, so that becomes a positive 4, equals m, -1/2, x minus x1, 6. Let me multiply the -1/2 inside the parentheses. And so I have y plus 4 equals -1/2 x. Negative and negative become positive. 6 divided by 2 is 3. Let me, so again, I would be done if they would allow me to write this in any form I wanted. But let me multiply both sides of my equation by 2 in order to get rid of all the fractions. Question. Oh, because it says here, it passes through this point and is perpendicular to this line. So it's perpendicular. So we don't want the equation of a line parallel to that other line. We want the equation of a line perpendicular to that given line. So we have this line, so somehow we have a point and we have a line. We want to find the equation of a line passing through that point but perpendicular to that given line. Okay, so that's why we had to take the negative reciprocal. So we found that this slope was like 2, but we wanted a line that's perpendicular, so it had a slope of negative 1/2. Okay. Only when they tell you it's perpendicular. So notice here, ah, here it said parallel. Problem number 40 said parallel. So we use the same slope. Here in 42, it said perpendicular. So we had to take the negative reciprocal. And in 52, it said perpendicular. So I had to take negative reciprocal. It depends on what the question asks. If the question says perpendicular, then you use perpendicular. If the question says parallel, then you must use parallel. So it depends on what the question is telling you. Okay. So let's multiply by 2. So I get here 2y plus 8 equals a negative x plus x. Let me add x to both sides of my equation. So I have here x plus 2y plus 8 equals 6. Let me subtract 8 from both sides of my equation. And so I have here x plus 2y equals negative 2. And so now I've written this in standard form. Notice that all the coefficients are positive. All the coefficients are integer valued. The coefficient in front of x is positive, and there are no common factors. Okay, so let me do one more, I guess. In exercises 69 through 80, find the equation of the line with the 2 points, and let's do this in standard form. Okay, so I guess I'll do one more of those. So problem number 75. One third one and 2/3 4/3. So let's call this x1 y1. Let's call this x2 y2. So let's find the slope. Through 2 points. So m equals y2 minus y1 over x2 minus x1. And so 4/3 minus 1 over 2/3 minus 1/3. So, maybe I'll do it this way since it's all over 3. Let me multiply each term by 3. And so if I do that, I get m equals 4/3 times 3. Well, the 3's cancel. I get 4. 1 times 3 is 3. 2/3 times 3, well, the 3 cancels, so I just get 2. 1/3 times 3, again, the 3 cancels, so I just get 1. 4 minus 3 is 1. 2 minus 1 is 1. 1 divided by 1 is 1. So the slope is 1. So now I'll use the point slope form for the equation of a line. So y minus y1 equals mx minus x1. And so y minus y1 1 equals m1 times x minus x1 1/3. And so I have here y minus 1 is equal to x minus 1/3. Let me multiply both sides of my equation by -3. And so if I do that, I get -3y plus 3 equals -3x plus 1. Let me add 3x to both sides of my equation. Let me subtract 3 from both sides of my equation. And so I get 3x plus 3y is equal to -2. So this is in standard form. All the coefficients are integer valued. The coefficient in front of x is positive, and there are no common factors. Thank you. That was a typo. Thank you. Yes, 3x minus 3y equals -2. Yes. Any questions about that? So that finishes off section 3.4, which means actually that finishes off today's lecture. Um, and so I guess I'll see you guys tomorrow. Any questions? If not, then that's it for today.